You know, we rely on our smart devices for pretty much everything these days. So when one of them, your router, your watch, maybe even your car, just suddenly crashes for no reason, it's more than just frustrating, it's a real mystery. So today, let's put on our detective hats and see if we can crack the case.
I mean, we've all been there, right? 1 second, everything's working perfectly, and the next, you've got a frozen screen or a device that won't respond. The real question is, what's actually happening behind the scenes? What's the invisible force causing this digital breakdown?
Well, a lot of the time, the culprit is something called firmware. You can think of it as the super specialized, invisible software that acts as the brain for our hardware. It tells your coffee maker how to brew, your car how to run. It's the critical, unseen program running our whole connected world. And when it goes wrong, everything just grinds to a halt. And that really gets to the heart of our mystery. A firmware crash is a lot like a crime scene. You know something has gone terribly, terribly wrong, but there are no obvious clues, no smoking gun. It takes a real digital detective to piece together what happened.
Okay, so that brings us to the first part of our investigation, finding that elusive root cause. We're going to dig into why finding the actual culprit behind these crashes is so incredibly difficult for security analysts, who are, for all intents and purposes, our digital detectives.
So you might be asking yourself, what makes this so hard to crack? I mean, why can't analysts just look at a log file and see exactly what broke? Well, it turns out they're up against a few major obstacles.
First off, there are often no witnesses. The systems running this firmware usually don't have the fancy debugging tools we have on our laptops, so when a crash happens, it leaves behind almost zero useful information. It's like a crime happened in an empty room with no one to interview.
The second obstacle? It's like showing up to a contaminated crime scene. See, to save space, firmware files are often stripped of all the helpful labels, like the names of functions and variables. So what you're left with is just a jumbled mess of raw code, making it nearly impossible to figure out what you're even looking at.
And to top it all off, our detective has to deal with a whole bunch of deceptive clues. There's this tricky technical issue called the memory alias problem. Basically, it means that multiple different bits of code can all point to the same spot in memory. This creates all these false leads that make it incredibly hard to trace a problem back to its true source.
So, with no witnesses, a contaminated crime scene, and a bunch of false leads, the case seems unsolvable. But, you know, every great detective story needs a breakthrough, right? What if our investigator had a brand new, high-tech toolkit? Well, let's meet the hero of our story, the FIRMRCA tool.
A team of researchers developed a new framework designed specifically to analyze what happens after a crash. It's called FIRMRCA. That's FIRMRCA. And it's basically a state-of-the-art forensic toolkit that's helping analysts crack these really tough cases.
FIRMRCA works in 3 main steps, and it sounds just like a detective's process. First, it does footprint collection. That's gathering all the evidence. Second, it uses something called reverse execution to basically rewind the tape and see how the crime unfolded. And third, it conducts a root cause analysis to identify the prime suspects.
So how does FIRMRCA solve that no witnesses problem? It's actually pretty clever. It uses these digital hooks to watch the firmware while it runs. Think of these hooks like tiny surveillance cameras, recording every single crucial memory access, every read, every write. This creates a super detailed log of events, just like a detective who's meticulously taking notes at a crime scene. Okay, so we've got a new tool, a new method, but does it actually work? Let's take a look at how this brilliant new toolkit really performs out in the field. The results are, and I'm not exaggerating, absolutely staggering. In a test across 41 real-world crash cases, FIRMRCA was able to pinpoint the root cause, the single instruction that started it all, within its top 10 suspects an incredible 92.7% of the time.
And this table here really puts it into perspective. When you compare it to the next best method, which has a success rate of just 19.5%, well, FIRMRCA is just a massively forward. It's also way faster and, this is crucial, it can analyze the entire chain of events leading up to a crash without failing, which is something other tools really struggle with.
And hey, don't just take my word for it. To put a finer point on it, the researchers themselves state that FIRMCA has a 73.2% higher success rate than other state-of-the-art tools. That's not just a small improvement, that's a complete game changer for firmware security analysis.
What's even cooler is that it's especially good at solving the coldest of cases, what the paper calls deep root causes. These are crashes where the initial error, the real crime, happened thousands of steps before the device actually crashed. FIRMRCA can trace that problem all the way back to its origin. So, we've seen how this tool works and just how effective it is. But what does all of this actually mean for us in our daily lives? Let's move to our final section and see how this helps secure our connected world. Because at the end of the day, this is about way more than just lines of code. It's about reliability and security. Finding the root cause of a crash is always the very first step to fixing a potential vulnerability, and that makes the technology we use every single day that much more robust.
And believe me, we are talking about a lot of technology. Firmware is literally everywhere. It's in our routers, our smartwatches, our cars, but it's also in really critical infrastructure. Things like medical devices and industrial control systems, where a sudden crash could have truly severe consequences.
This really leaves us with a final thought to chew on. Tools like FIRMRCA are our digital detectives, right? They're investigating the invisible software that pretty much runs our lives. But as this software gets more and more complex and more hidden away from us, it begs the question, how do we build systems and tools that allow us to fundamentally trust the code we can no longer even see?